This last section here is on solving radical equations and inequalities. Okay, so we've been working with radical expressions with those roots. Okay, now we want to solve some equations involving radicals. So, radical equations include radical expressions. You can solve a radical equation by raising each side of the equation to a power. Okay, so to get rid of that radical, you're going to raise that expression to a power. So your steps are laid out below here. So first step is to isolate the radical on one side of the equation. Okay, so if you have any type of root, you want that whole root on one side of the equation and everything else on the other. Step 2, raise each side of the equation to a power equal to the index of the radical to eliminate that radical. Okay, so if it's, say, a cubed root, you'd raise it to the power of 3. If it's the sixth root, you'll raise it to the power of 6. Okay? Step 3 is to solve the resulting polynomial equation and then check your results. It is important to check your results because you could get a solution when doing this that doesn't actually work. Okay, so you have to plug in what you found for that variable to check it. Okay, so we're going to go through some examples. So first example here. We have 5 is equal to the square root of x minus 2 minus 1. Okay, so we want to isolate that radical. We want to get it by itself. So to do that, I'm going to add 1 to both sides of that equal sign. Okay, so I'm adding 1 to both sides. So I end up with 6 is equal to the square root of x minus 2. So now I've isolated that radical. Now the index for this one is just 2 since it is a square root. So to eliminate that square root, I'm going to raise it to the power of 2. Now whatever I do to one side, I have to do the other side.
Wow.
Okay? So I'll have 36 is equal to x minus 2. I'll add 2. And x will be 38. Now you do need to check that answer. Okay, that's part of this process is to check your answer. So if I'm checking this answer, I'm going to plug in 38 for x in my original. So I have 5 is equal to the square root of 38 minus 2 minus 1. Okay, so I have 5 is equal to the square root of 36. So you have to do whatever's underneath that radical first.
What? That's true.
Then minus 1.
It's right.
I know, but you got to write it out. So we have 5 is equal to 6 minus 1.
Which is 5.
True.
Which is 5. So that is true. So this is your answer.
So what if it's false?
Then it would be no solution.
Okay.
Wow.
It's going to get 20 times harder.
Oh.
So letter B, a little bit different here. So we have a radical on both sides of this equation. No, I'm going to keep it like it is. Shh, quiet, please. So since I already have one of my radicals isolated here, I'm going to raise it to the power of 2 right away. Okay, so I'm going to square both sides right away. So on that left-hand side, your root just cancels out. So you just end up with x plus 15. However, on the right, you have this addition between your two numbers. Okay, that means you need to FOIL this. So if you need to, off to the side, write 5 plus the square root of x times 5 plus the square root of x. So 5 times 5 is 25. 5 times the square root of x is just 5 square root of x. Square root of x times 5 again is 5 square roots of x. And then square root of x times square root of x is just x. Okay? So, I don't know what to tell you. I don't want to turn off the lights. So here, we're going to plug that back in over here because I squared this side now. So we have 25. I'm going to combine like terms here. So I have a 5 and a 5. That makes 10 square roots of x plus x. I'm going to subtract x on both sides. Now what happens is both of them cancel. Okay? So I have x minus x and x minus x. Okay, so I have 15 is equal to 25 plus 10 square roots of x. Again, now you want to isolate that radical. Okay, so we want to get that square root of x by itself. So I'm going to subtract 25 from both sides. So I have negative 10 equals 10 square root of x. We're going to divide both sides by 10. Divide them. So they cancel right here. If I have negative 10 over 10, it's just negative 1. And that's equal to the square root of x. Now that I've isolated that radical, I can square both sides. Okay, so I'll end up with x is equal to 1. And then we got to check it. Okay, so off to the side, before you circle it, you want to check to make sure that's an actual answer. So we'll plug 1 in for x into our original up here. So we have the square root of 1 plus 15 is equal to 5 plus the square root of 1. So we have the square root of 16 is equal to 5 plus 1. So we have 4 is equal to 6. That's not true. Okay, so this would end up being no solution.
I knew that from the start. Just like how we have to use.
Okay, so that number is actually called an extraneous solution. Okay, it's called an extraneous solution, so you get that answer, but it actually doesn't work out. Okay, any questions on example 1? Okay, again, if you have this plus or minus, you do need to FOIL it. Okay, don't just distribute that square, make sure you're FOILing that out. All right, so example 2 has a rational exponent. So those are what we were working with the 2 days prior to today, so last 2 days. It's that fraction as your exponent. Okay, that's still considered a radical or a root, okay, because you can change it back into radical form. So we're still going to solve for x in this case, except we're going to do it with our rational exponents. So we want to isolate what that rational exponent is around. So whatever's in that parenthesis there. So first here, I'll add 4 to both sides of that equation. So we have 2 times the quantity 6x minus 3 raised to the 1/3 power. That's equal to 4. Okay, and again, I want to isolate those parentheses, and I still have that 2 out front. So since those are multiplied together, I'm going to divide both sides by 2 so that they cancel out right here. So we have 6x minus 3 to the 1/3 power is equal to 2. Now what power do you think I'm going to raise this to get rid of that rational exponent? Yes. So I'm going to raise this to the 3rd power. Okay, I'm going to do that so that when I multiply those two exponents, it creates a 1. Okay, so I have 3 times 1/3. That's just 1. And I have to do that to the other side as well. Okay, so I have to raise that to the power of 3. Yes, so I'll have 6x minus 3 is equal to 8. Add 3. Okay, so I have 6x equals 11. Divide by 6. Okay, so x should be equal to 11 over 6. And I'm going to leave it like that so it's a little bit easier to check. So even in these ones, you still need to check that your answer is correct. Okay, so off to the side. Off to the side, we're checking. So we're plugging in 11 over 6 for x. Okay, so we have 2. Quiet, please. 2 times 6. Plugging in 11 over 6 for that x. Minus 3 to the 1/3 power minus 4 equals 0. Okay, so I still have this 2. I can simplify in here. So if I have 6 times 11 over 6, so 11. Your 6's will cancel. So you have 11 minus 3 to the 1/3 minus 4. Okay, 11 minus 3 is 8. Eight to the 1/3 power. What's the cube root of 8? Yep, is 2. Okay, so we have 2 times 2 is 4 minus 4 equals 0. And we have 0 equals 0. That is true. So x does equal 11 over 6. Okay, just leave these as fractions because it'll be easier to check in the long run. Typically, those denominators will cancel with what it's multiplied by. Questions on how we did example 2?
I'm still giving her on a check mark, so
Okay. So again, make sure you're isolating that radical part or whatever your rational exponent is attached to. Okay? So you want to isolate that first so that you can raise it to a power to get rid of it.
Good deal. All right.
I'm almost done.
I'm waiting. Give me a second. We have another example on the back. I want you guys to try that one. I already did.
Can you show me how?
No, I want you to do example 3. Isolate your radical. Okay? Example 3. Isolate this 6th root. Then raise it to a power on both sides.
It doesn't even have step ups.
Alright, example 3. Quietly. Do example 3, please.
I was checking, making sure I did that right. And I did, and I know it. Does this work with Photomath? Anyone got that?
So we're gonna.
What? Yeah. How much further did you get on your problem?
I got both ready to go. I did all. Yeah, I got the one on the computer. There you go. So it'd be like years. I did it, but I'm not. 2 times 2 is 4. 4 times 2 is 8. Hey, you know how many students right now? And then it would go 16. 16 times 2 is 32. Why'd you park on the road? I hit your truck.
It has a solution. Alright, so looking at example 3, quiet please. Hey, focus.
I'm focused on something.
No, this over here.
I'm focusing on life stuff, not.
No. Okay, so we want to isolate this radical in parentheses here. Okay, you want to get that by itself. So you add, too much talking. Do you need to be doing that right now? You add 4 to both sides. So we have 7 times the 6th root of 5m plus 4 equals 14.
Oh, I got that. Yeah.
We can divide both sides by 7. So we have the 6th root of 5m plus 4 equals 2.
Yeah, we do.
Now since this is a 6th root, we can raise this to a power of 6 on both sides. Okay? That cancels out your root and your power over here. So you end up with 5m plus 4 is equal to 64. 2 to the power of 6 is 64. Subtract 4. So we have 5m is equal to 60.
M is equal to 12.
Yes.
I told you.
Okay, now, Keegan. Now, we need to check. Okay, so off to the side, we're checking the answer. So we'll plug in 12 for m. So we have 7 times the 6th root of 5 times 12 plus 4 minus 4 equals 10. Okay, so we have 7 times the 6th root of 60 plus 4 minus 4 equals 10. So 7 times the 6th root of 64. The 6th root of 64 is 2. So we have 7 times 2 minus 4, which is 14 minus 4.
Which is 10.
Which is 10, which is 10. So 12 is your answer.
I wasn't right.
Wow.
You said no solution.
And I said it's 12. You said no, it's wrong.
I did not say anything after I said it's not no solution. All right, so those are the equations. Now we're going to do inequalities. Okay, so an inequality has that less than or greater than or less than or equal to or greater than or equal to sign. Okay, those are your inequalities. So I have out the following steps to solving an inequality. So if the index of the root is even, you need to identify the values of the variable for which the radicand is non-negative. So like before, when we were finding the domain of a radical function, okay, you need to see where that is non-negative for these problems. Okay, so you have to set whatever's underneath your radical greater than or equal to 0. Okay, that's your first step. Next is to solve the inequality algebraically. So same process as we just did for the other problems. And then step 3 is to test the values to check your solution. So you're not plugging it back in. Okay, we're going to draw it out on a number line so we can check our solutions. Okay, so for example 4, your first step is to take whatever is underneath your radical. So in this one, letter A, that's 3x minus 6. Okay, we're going to take whatever's underneath that radical and set it greater than or equal to 0. Okay, that has to be greater than 0, otherwise you get imaginary numbers. So we have to make sure it's greater than a certain number. Okay, so it's non-negative. So here I just want to solve for x. So I'll add 6 to both sides. Divide by 3. Okay, so x has to be greater than or equal to 2. Okay, that's the first part. Now I can go through and solve for x with the whole thing, just like I was before. Okay, so here I need to isolate the radical. So I'm going to subtract 4 from both sides of that equation, or inequality. So I have the square root of 3x minus 6 is less than or equal to 3. Okay, so I isolated that radical. Now since it is a square root, I can raise both sides to the power of 2 so that it cancels out that radical. So I end up with 3x minus 6 is less than or equal to 9. So add 6 to both sides. So we have 3x is less than or equal to 15. Divide by 3. X is less than or equal to 5. Now instead of plugging that back in, okay, we're going to draw out this number line here. Okay, my two values I have are what I found the domain error to be, okay, or the domain to be of 2, and what I found my equation to be less than or equal to is 5. So I'm going to plot on here 2 and 5. Okay, and it doesn't have to be perfect. You don't have to make every single number. Okay, as long as 2 is to the left of 5, like a normal number line. So from here, my x value has to be less than or equal to 5. Since it's less than or equal to, I'm going to draw on a closed dot. Okay? And it has to be less than that. So we're going to the left. My other one is 2. Again, that's an equal to one, so it's a closed dot. And x has to be greater than that, so we need all of the numbers greater than that value. Now with this number line, you just want to see where they overlap, okay? So where they overlap would be here to here, okay? That's your overlap for this one. So it's in between. So that means I'd have to write x is greater than or equal to 2 and also less than or equal to 5 as my answer, since it's in between. Sometimes with your domain, you'll get it where, say it's less than or equal to -1 and greater than or equal to 2. Okay, it's in opposite directions. There's no overlap. That would be no solution. Okay? So, last one. Letter B. We need to check our domain first underneath our radical. So that 2x plus 2 must be greater than or equal to 0. Okay, that's your first step with radical inequalities. Solve for x. So we have 2x is greater than or equal to -2. Divide by 2. X has to be greater than or equal to -1. Okay, now I can go back to my original and actually isolate that radical and solve for x. Okay, so I want to subtract 1 from both sides to get that radical by itself. Okay, so I have the square root of 2x plus 2 greater than or equal to 4. To cancel out the radical, we raise it to the power of 2 on both sides. That cancels out that radical there, so we are left with 2x plus 2 is greater than or equal to 16. Subtract 2 from both sides. So we have 2x is greater than or equal to 14. Divide by 2. And x is greater than or equal to 7. Okay, now that I have my two numbers here, we'll draw in this number line. We have -1 and +7. So -1 on the left, +7 on the right. What? -1 is less than 7?
No, more than.
No? So with x greater than or equal to 7, that's a closed dot at 7, and it has to go and be numbers greater than 7, so to the right. With x greater than or equal to -1, again, that's a closed dot, and all the numbers that are greater than -1. Now your overlap for this one is over here, and they're going to keep continuing. That means your answer is just x is greater than or equal to 7. Okay, so if your overlap just continues, you just go from that overlap. Okay, so x will be greater than or equal to 7. And you won't need to include the -1. Questions?